Well, our mousetrap begins at the Jenga blocks when one of our hands touches the first one, and it creates like a domino trail and then falls down this tiny little ramp, and it hits the bouncy ball, which rolls down this ramp and triggers the train of dominoes, then hits this very small marble right there and rolls down the ramp through the tube, and it hits this matchbox here, and then the matchbox transfers its energy to the other trail of dominoes up the Jenga ramp.
According to the U.S. Patent Office, there are over 4,000 patents for mousetraps.
Large marble, and it rolls down and hits the box, and all the while one of us is pulling the mouse, and the mouse will end up right there, and the box will fall on top of it.
And if you were ever going to build a better mousetrap, the Armada Academy of Arts and Sciences may be just the place to make it happen. The Armada Middle Academy of Arts and Sciences is a magnet school that focuses on accelerated curriculum for math, science, technology, and the arts. It's part of the Armada School District, made up of students from Macomb and St. Clair counties. The Armada Middle Academy of Arts and Sciences is a hands-on school. Beginning in the 6th grade, students are immediately eased into learning through experience by touching, feeling, building, and dissecting, all the while integrating math and science along the way.
The Armada Middle Academy of Arts and Sciences is really a unique program, I think, in the country. It's modeled after the high school program here in Armada, the Macomb Academy of Arts and Sciences. And the centerpiece of the program is research. So I think that's very unique that all students are coming up with their own questions and then going through the whole scientific method in order to answer those questions. So it takes it through creating a hypothesis and then coming up with research questions, designing an experiment, actually conducting the experiment, collecting the data, doing the analysis, and then we also require that they do a public demonstration of their data.
The research project lasts the entire semester. At the beginning of each semester, students are offered a substantial list of long-term project ideas. They form teams and choose one of the projects in which they will design their experiment and hope to prove or disprove a hypothesis. From here, the wheels are in motion, and they take charge of their learning. Taking responsibility for their learning is the motivating factor that drives them. They become independent thinkers and are not afraid to take risks.
There's some frustration at first, but once they realize that they can accomplish it on their own and we're kind of give them the look like you can do this, just use what you got, they'll go out and they'll figure it out on their own.
When they first come into the academy, they do not like the open-ended questions. They want an answer. What do you want? How many pages? What does it need to look like? But they soon, when you start to let them explore their own interests, then you get so much more from them than you would have had it just been a traditional type setting.
In the academy, we really want the students to be able to succeed in the long run. We obviously look at short-term goals, but we don't want the students to just memorize the facts and master them at that current time. We want them to be able to take the information and be able to apply it down the road, and again, to apply it to real-world situations. We don't want to just hand them a recipe and say, here, follow it. We want to say, here's the kitchen, we want you to make cookies, figure out how you're going to get there. So it really allows the students, it allows them too to take their own path on how they're going to essentially make those cookies. It really allows them to express themselves and, show off their strengths. Some students are very strong artistically, some students are very strong in the technology sense. They really are able to show off their strengths.
So for my project, basically what I did was I set up 5 different distances, 10, 15, 20, 25, and 30 yards away, and I shot paintballs at each of the distances to see how they would affect the size of the splat of the paintball. For my hypothesis, I thought that as I got further away, the splat size would decrease because the speed was decreasing. And during the project, as I was testing, I began to notice the trends that as I got further away, my hypothesis was correct that the splat size decreased.
My project is Going Green. I mainly did this for the environment to show that we don't have to be so wasteful. And what it is, I made a completely green generator. It shows what it works is that these magnets right here, these 4 magnets spin around inside this coil. When they spin, they release their electromagnetic energy into their magnetic field. And as they spin, the magnetic field travels to this wire, 'cause it's the next magnetic thing. And then the wire runs off to my negative and positive charges, which run to my volt reader right here.
And I thought it'd be cool to do land pollution because as soon as she told us that we were supposed to do a pollution project, I kind of envisioned a tree just made out of trash. And then I kind of thought of the idea of doing a before and after, and I consulted my group, and they thought that it was a really cool idea. So we kind of built off of that. And then once we got the before and after part, we started we picked deforestation because of the actual concept of it being a tree. And then we picked littering because I don't know why, but I just kept on thinking of a tree that was made out of trash.
It's Newton's first law of inertia, and it tells that an object in motion will stay in motion unless acted upon by an outside force. If it wasn't for Colin pushing this truck, nothing would move. And then once the truck hits this tube, it stops moving because